20 minutes. Okay. So guys, let's start with trig. No? So trig, I'll just try to brush up the things and explain the most important things. No? So what is trig? What is trigonometry? What is trigonometry? What is trigonometry? What is trigonometry, guys? What is trigonometry? So this is mainly the geometry of what? Of mostly triangles. So we're going to deal with triangles a lot, right? So dealing with triangles, so these are firstly we're going to deal with the right angled triangles, which are very simple. Ne? So trig is divided into 3 sections. Ne? There's a trig, the right angled triangles, and then we're going to go to trig of triangles that are not right angled, ne? Which we call 2D, 3D. Ne? And then we have functions in trig, right? So I often tell people that there are 6 types of trig questions. If you are dealing with this first part of trig questions, right? There are 6 types of trig questions, which they just repeat over and over again, right? So we're going to learn how we can approach those types of questions, right? So these questions, we approach them in different ways. So the first trig question and the second trig question, they're mostly the same, right? The first and the second, they're mostly the same. And also we have the third and the fourth, they're also mostly the same, right? The third and the fourth, they're mostly the same. And then we go to the fifth and the sixth type, they're also mostly the same, right? So if you can be able to solve this, you can also be able to solve that. If you can be able to solve this, you can be able to solve that. This and that also there fall in the same category, right? So let's start from this trigonometry. So what I'm going to teach you now, I'm going to teach you the tools that you can use to solve this type of question, right? The tools that you can be able to use to solve this type of questions, right? So first thing first, let's talk about this. What does this say? Pythagoras, right? So it means that in a right angled triangle like this is our 90, right? And this is our h, right? And most of the time we call this y and this is what? X, right? Why do you call this x? Because it is, if you are drawing a Cartesian plane, this is the x-axis and this is the what? The y-axis, right? So what does Pythagoras say? It says that our h squared, or this we often call it r as well, right? Which is the radius, right? Which is always positive, right? So we say h squared is equal to x squared plus y squared, right? I'm sure all of you can use this, right? Even if you're not having this, you can be able to solve that, right? Using theorem of Pythagoras, right? So this is our first tool that we're going to use whenever that you're solving these 2 types of questions, right? We use them there, right? From this, we have these guys. We have to understand again what is it that we talk about in trigonometry. So in trigonometry, mostly we talk about the ratios, right? The ratios. What are the ratios that we talk about in trig? Mostly we talk about 3 ratios, right? What are they? We talk about sine theta. We talk about what? Cos theta. And we talk about what? Tan theta, right? So what is sine theta? If you are having our right angle triangle like that, what is sine theta? So it means that our sine theta, so here I'm trying to keep 2 bases with 1 square. So it means that if you're having this, this is our theta, this is our h, this is our opposite, and this is our adjacent, right? And at the same time, we can also have something like this. And again, this is our what? Our r, this is our what? Our y, and this is our x, right? Whenever you don't understand, please just say so, and then I'll stop. So, what is sine theta according to these 2 different diagrams? This diagram talks about adjacent, opposite, and hypotenuse. And that other one is talking about radius, x and y, right? Which often we use this one, right? So what is the value of sin theta according to this? We know that sin theta is equal to what? Opposite over hypotenuse, right? But we're not talking about in terms of this. We know that sin theta is equal to what? Y over r. These are the tools that we are going to use, right? Next, what do we have? We have cos of theta, right? According to this, cos of theta is equal to what? It's called, according to this one, a over h. And according to this one, it will be what? It will be x over r, right? And again, we have this tan theta, sorry. So what is the value of tan theta? According to this, it is what? A over O over A, right? And according to this, y over x, right? So that is that in terms of cos theta, tan theta, and tan theta, right? So let me just write them here in terms of x and y so that they don't skip us, right? So it says tan theta is equal to what? Y over r. And it said cos of theta is equal to what? X over r. And then we said our tan theta is equal to what? Y over x, right? So here I'm talking about what? Can I? So here what am I talking about? I'm talking about if we are having our what? If we are having our shape like this, and we say this is x, this is y, and this is r, right? That's what we are talking about, right? Okay. So this is the second tool that I can give you. So I gave you two tools for now, right? I gave you Pythagoras, and I gave you the what? The ratios, right? So is there anyone that can say they don't understand the Pythagoras and they don't understand the ratios? No, right? Okay. So what is the next thing? The next thing we're going to deal with the Cartesian plane, right? We're going to deal with the Cartesian plane a lot. We're going to talk about the Cartesian plane for a number of minutes, talking about Cartesian plane. So if we're having our Cartesian plane like this, as we said, this is our x and this is our y, right? And from here going there, it is the positive x, right? From here going there, it is the negative x, and this is our zero line. And going up, it is our positive y, and going down, it is our negative y, right? So now on the Cartesian plane, what are we trying to talk about now? We're just trying to talk about where is what positive and where is what negative, right? So if we check, we said sin theta is equal to what? Y over r, right? So whenever we are drawing our angle in this quadrant, where do we place our angle? Is it here or there? We place it down here, right? So our theta is always there, right? So we show our theta between the radius and the what? And the x-axis, and never between the y and the what? And the radius, right? So our angle should always be between the what? The radius and the x-axis. Can you see that? Like this. So these are our radius. And I said the radius is always positive, right? So if we're talking about sin theta here, we know that sin theta is equal to what? Y over r. If we check in this quadrant, y is what? Positive. What about r? Positive. So it means that sin theta it is positive, right? So it means that sin theta is positive in the first quadrant, right? What about cos theta? It is x over r. And x is positive, r is always positive. So it means that our cos theta is positive, right? If we're talking about tan theta in this quadrant, we know that y is positive, r is positive, x is positive. So it means that tan theta is also positive in this quadrant. So it means that in the first quadrant, all ratios are positive, right? And then we go to the second quadrant. In the second quadrant, what are we talking about? What about sin theta? Sin theta is y over r. Our y is positive. Our r is positive. It means that sin theta is positive in here, right? What about cos theta? Cos theta is x over r, right? And our x is negative. Our r is positive. Negative divided by positive becomes what? Negative. So here we are having the cos which is negative, right? What about tan theta? Tan theta is y over x. Our y is positive, our x is negative. So it means that it becomes what? Negative. So here we are going to have negative tan theta. So it means that only sign is positive in that quadrant, right? And then we move to the third quadrant. So this is our first, our second, our third, right? So in the third quadrant, sign again is y over r. Y is negative, r is positive. So sign becomes what? Negative, right? What about cos theta? Cos theta is x over r. Our x is negative and our r is positive. So it means that cos becomes what? Negative, right? What about tan theta? Tan theta is y over x. So it is negative y over negative x. And negative divided by negative becomes what? Positive, right? So this gives our cos here, our tan to be positive. So tan is positive, but the rest they are what? Negative cos theta and negative sin theta, right? Only cos is tan is positive here, right? And then we move to the fourth quadrant, right? Sin is y over r, right? So this is our y over r. Our y is negative, so sin becomes negative, right? What about cos theta? Cos theta is x over r. Our x is positive, right? So if our x is positive, it means that we are having positive what? Our cos becomes positive, right? What about sin? Sin we said it is negative. Sin theta. What about tan? Tan is y over x. Y is negative and x is positive. So this becomes negative. So what does this mean? It means that for us to have a positive sin theta, right? We are talking about the first quadrant and the what? And the second quadrant, right? And for us to have a positive cos theta, it should be in the what? First quadrant and also in the what? Fourth quadrant, right? And to have a positive tan theta, it should be talking about what? First and third. Is this making sense? Is this making sense? Yeah? Right? So it means that if I give you something like this and I say, where is tan theta less than 0? Where is tan theta less than 0?
Second and fourth.
It is the second
And fourth.
and the fourth quadrant. Tan is less than 0, right? And then if I say, what am I talking about? It's positive, right?
Yes.
And where is it positive?
First and second.
Second and first, right? And if I say, which quadrant am I talking about?
Cos is negative.
Third
And
and
the second and the third.
Second and
third.
So, and again, still on the Cartesian plane, right? Still on the Cartesian plane. Let me just talk about this, right? So if we are trying to calculate, to find our angles, we count our angles in the anti-clockwise. So it means that anti-clockwise is positive and clockwise is negative, right? So it means that this is our 0 line, right? So it means that when we're counting like this, we're doing what? We're edging, right? So going like this, we're doing what? Subtracting, right? So here it is our what? 90, here it is our what? 180, here it is our what? And then it comes back to what? 360, right? So it means that if we are having any angle that is in the first quadrant, right? This angle can either be represented by what? By theta or by what? 90 minus theta. Because 90 minus theta, now we are subtracting, it means that we are going back. We are at 90 and we are going back theta times. So it means that 90 minus theta falls in this quadrant, right? And also we can have 360 plus theta. What am I trying to show you? I'm also trying to show you the what? The reduction formulas that to use in each of the quadrants, right? So in the first quadrant, we use these reduction formulas, right? And you go to the second quadrant. If you are at 90 and we are adding, what do we do? So it will be 90 plus theta. And if you get it 180 and we are subtracting, it is 180 minus theta. So it means that in the second quadrant, we are going to use these reduction formulas, right? But these ones, we talk about them afterwards, right? And this one. These are called what? Co-ratios, right? We'll see when we do them, right? And when we get to 180, if you decide to go forward, it will be 180 plus theta, right? And here going back, 270 minus theta. Going forward, 270 plus theta. And then going back, 360 minus theta. Or we can also have what? Negative theta, right?
Yeah.
So if I'm to ask you, is this positive or negative? Cos negative 20, is it positive or negative?
It's positive.
If I do like this, cos negative 20, I'm going to get a positive value and negative value.
Positive.
Positive value, because if you are saying minus, from 0 the minus, you are going in the what? Fourth quadrant. And in the fourth quadrant, cos is what?
Positive.
Positive, right? So if I give you cos 225, is it positive or negative?
Positive.
Positive.
Negative.
225, it is negative, right? Because it is in the what?
Third quadrant.
Third quadrant, right?
Yeah.
What about sine 179? It's positive because it is in the what? Second quadrant, right? About quadrants, are we okay? So this is the other two talking about quadrants. Yeah? So now you know which one is where and how, right? Okay. So now, with this that I've shown you here, we can be able to solve the first trig question and the second trig question, right? With this that we did right now, we're able to solve two types of trig questions, right? So let's see what I'm trying to say, right? As simple as that, right? I can erase, right? Is there anyone with a question paper or that next F? Let's move right there. So the first question is very, very simple, and the second one is the one that is a bit challenging, but it is also simple, right? So we are doing the first trig question, right? So first, let's do the first trig question. Ne? So the first trig question now is it like, it comes like this, right? If cos 62 is equal to k, right? If cos 62 is equal to k, and then they say determine in terms of k, right? The following, right? We're determining the following in terms of k. So the first question that we'll determine is sine of 28. And we're going to also determine the value of cos 242. Right? So how can we deal with this one? So we have two questions that we have to solve, right? And we have this here that we are given, right? So how do you solve this first trig question? It is very, very simple, right? How do you solve it? We solve it in this way. It is saying cos 62 is equal to k, right? Any number that is placed on its own, it is the same as, if you're having 5, it is the same as 5 over 1, right? So this k, it is the same as k over 1. And what is the ratio of cos? Cos is what? Adjacent over hypotenuse. So it means that this is our adjacent and this one is our hypotenuse, right? And our angle is what? 62, right? So it means that we are going to draw a simple diagram like this, right? And we are going to place our 62 there, and this is our 90 there, right? So if this is our 62, what is the angle there? This is 90. What is the angle there?
28.
It will be 28 because of the sum of angles in a triangle must give us 180, right? So this becomes 28, right? So now our angle is this, and our adjacent is K, right? So it means that on the adjacent you are just going to place K. What about our hypotenuse? 1. So we are going to place 1 there, right?